All right, welcome back. Section 3, Module 3, Trigonometry, all about right triangles with a little bit of transformations. Big one, big one for us. A couple things. Unfortunately, you don't get a formula chart on the TSI, so you got to memorize it. Got to know sine, cosine, and tangent. Got to know Pythagorean theorem. I would recommend to at least know this stuff, the reflections. It's not the end of the world if you don't memorize these first two. For sure, this one, though, y equals x. Not as intuitive to get to this part here. Yeah, I would say as well, rotation just in case. So all that means here for transformations is basically what's happening to the point. So in this case, you have a point at x, y, and it moves with this rule, x minus 2, y plus 4. So if you have a point just anywhere on the graph, well, actually not anywhere specifically, at x comma y, so I had a positive x and I had a positive y, so anywhere in this region. Thankfully, transformations are basically what you think they do. Like x goes left and right, so if it's x minus 2, that means it's going to the left 2. Y goes up or down, so if it's y plus 4, that probably means, or it does mean, it's going up 4. So it's just describing what's happening on the coordinate plane. Same idea here. Now, there is a rule for reflection across the y-axis. The rule, if you want to memorize it, that is awesome. I love it. Here we go. Take the graph, switch the sign of the x. So if the x was originally positive, now it's negative. If it was negative, now it's positive. So the sign of the x value, which is a in this case, would end up being swapped. I will say, though, especially for reflections, if you don't want to memorize it, and this is a really good idea for like other stuff in general, when it's really abstract with variables, replace those variables with numbers. I'm going to pick two random numbers, 5, 7, okay? Actually, I'll do 3, 7. So boom, boom. Here's a 3, 7. Why not? We want to reflect this point across the y-axis. That reflection, maybe you heard the word flip. Basically, if you treat the y-axis as a mirror, it is mirrored in the exact same place. So if it is 3 units away from the y-axis here, it better be 3 units away from the y-axis here. So if this was positive 3, this has to be negative 3. Now, do notice it's going to be on the same line for the y values. So the y value wouldn't flip, just the x. We could then make the conclusion, oh, when you're flipping across the y, you just change the x value. Hence, negative a comma b. Taking something that's super abstract and making sense of it with numbers that are a little bit easier to work with does kind of help get the point across. Now, for this one, this is just a definition. If you reflect across the line y equals x, this is called an inverse function. So in this case, you just got to know it, unfortunately. I do like inverses because they're super simple. Swap them. So if you have originally x comma y, now it becomes y comma x. So 3, negative 7, now it becomes negative 7, 3. Fun stuff there. All right, Pythagorean theorem. We love it. We got to use it. Okay. They may or may not give you a picture. So in this case, if you haven't already especially, it's silly. Draw a picture. You know it's going to be a right triangle. So draw a picture. Great. Hopefully your picture looks something like this. We have a 12-foot pole. And you get a string that's from the top of the pole to the ground. So that's a 20-foot string. How far is the stake from the base of the pole or that bottom length of the triangle? Now, a couple things always with Pythagorean theorem. Please be careful here. The C value is always the hypotenuse. Hypotenuse is always across from your 90-degree angle. I love to label that part first in any right triangle, just so I know C squared is by itself. A and B doesn't matter. This could be A, this could be B, A or B. But it does matter what is C. So in this picture, they actually give you the C value. They don't give you A or B respectively. So when you do your Pythagorean theorem, you had to keep that in mind. Oftentimes, if you don't, they would give you an answer choice that, like, if you did like A squared plus B squared, they would get an answer choice that's very, very similar here to that. So in this case, I'll just treat, A squared plus B squared equals C squared. I'll treat X as the A squared part. 12 squared equals 20 squared. Okay, calculators are our friends for a reason. So use a calculator to say 12 squared is 144, 20 squared is 400. Quick thing real quick. This is just a side note. We had to square it first, and then we had to subtract. You cannot subtract 12 squared and then do 20 squared minus 12 squared is 8 squared. That is not how we approach the Pythagorean theorem. Notice here, if we subtracted 144 from both sides, that would be x squared is equal to 256. And the square root, that's how you get rid of the square, of 256 is actually 16. If we didn't do that, and we did here, subtract 12 squared, get you 8 squared, and that would be 64, and the square root of 64 is 8. Ooh, you would have got the wrong answer. So please be careful with Pythagorean theorem especially. Thankfully, it is just using Pythag. So I always recommend to do two things. One, if there's not a triangle, draw a triangle. Two, what are they asking for? Good thing to identify. And then three, always identify the hypotenuse, because that part will mess you up. Pause the video if you haven't drawn this already, or if you haven't done it. Awesome. Diagonal. I don't like that in red. Perfect. The length is 4x and the width is 3x. Looks like the width is bigger in my picture. My bad. That's fine. And you have a diagonal path that cuts straight across the park. So it's maybe something like this, which makes this a right angle and makes this one the hypotenuse. So the good news is we had the value of A and B, and you're trying to figure out the value of C. So nothing too crazy there. Be careful, because it's 3x squared, 4x squared. That squared applies to the 3 and the x. So there's not just 9x, it's 9x squared, 16x squared. Combine 9x squared and 16x squared to be 25x squared. I am running out of space, oh man. But that would end up being the square root of c squared, and the square root of c squared in that case would just be c, which we love. Square root of 25x squared. Two different ways to approach that. Do the square root of 25, then do the square root of x squared. Another way is to think to yourself, I need a number times itself to give me 25x squared. Would be 5x in this case. Either way still gets you the same answer, which is 5x. Trigonometry. Trig. Love to see it. Got to memorize it. Sine, cosine, and tangent. You just got to know it. Biggest thing about sine, cosine, and tangent, it's based off of two things. One, it needs to be a right triangle. Okay? And two, it's talking about in reference to some angle. So if our angle here is at the bottom, we call that theta. I know it's very blurry in this picture. Across from it is the opposite. Hypotenuse, we just said earlier, always across from 90. And the other side is called the adjacent. Do notice that if I was to draw my triangle like this, with the angle up here, your hypotenuse does not change. However, this side is now your opposite. And this side is now your adjacent. So it's based off of whatever angle we're talking about. So when we say sine of an angle, that does matter. So like down here in a little bit, we'll look at angles A, B, and C. It matters which one's A, which one's B, which one's C. Now, in this right triangle, I'm just going to pick this angle to be A, because why not? I could pick the bottom one to be A if I really wanted to. It does not matter for that part. But if I make that angle A, this one has to be B, and this one has to be C, right? If it says sine of A, never make that angle your right angle. I mean, that at that point, that you want to be able to use Pythagorean theorem. Okay, in this case, what is the value? Oh, I don't like that eraser. Perfect. It's saying, hey, you have a right triangle. Sine of A is 7/25. What's the value of tangent of A? Well, I like to always do two things. Draw your triangle, and then label your sides. You got your opposite. You got your adjacent. You got your hypotenuse. Let's see what they give you. By definition, sine of an angle talks about the opposite side and the hypotenuse. This picture or this question gave you that sine of A is 7/25. That means your opposite side is 7 and your hypotenuse is 25. So we know that this number is 25. We know that this number is 7. They want to figure out what is your tangent. By definition, tangent represents your opposite side over your adjacent. Thankfully, we have the opposite side. It's 7. Yay. We don't have the adjacent side. That's a mystery to us. I'll say X. So, take a second if you haven't already. How do you figure out the adjacent side? Hopefully, you got to the conclusion that, hey, you have two sides of a right triangle. Therefore, we can use Pythagorean theorem. So in this case, and I'll use it right here on the side, we have our C squared. We have an A or B. You want to figure out the other one. So I'll say the A squared is X. 7 squared equal to 25 squared. Calculators, we love them for a reason. So X squared plus 49 equals 625. Subtract 49 on both sides because you want to solve for X. 625 minus 49 is 576. From there, you notice that, oh, it's an X squared. You want to solve for the value of X. So the square root of X squared is X. And the square root of 576 would be 24. All that to say, hey, in your picture, the value of X is 24. Therefore, your adjacent side is 24. So what is the tangent of A? The tangent of A is the opposite, 7, over the adjacent, 24, which is A in this case. Same idea between number 7 and 8. So especially if you haven't tried it already, take a second. Draw a triangle, label your sides, see what you can do. I will say for number 7, though, it uses a key word we haven't really discussed called angle of elevation. So let me kind of draw out what this is saying. We have a tower. We don't know how tall the tower is. And it's saying a surveyor is measuring a tower's shadow as 120 feet. So if this is a tower, pretend like the sun's over here. So if the sun is beaming down, let me draw my little sun, my little sunshine, my only sunshine. If it's beaming down on this tower, the shadow will be here on the floor. So that shadow is 120. Now, I use this analogy because pretend like you're sitting here on this floor and you're in the shadow of this tower. And if I said, hey, look up to the tower, you will be looking up at this angle. Like you're right here. You'll be like, wow, look at this big tower. Your eyes will be horizontal and then they'll be looking up. All that to say this, angle of elevations are basically looking from the ground up. So it started at 0 and it looked up 35 degrees. You may hear another key phrase called angle depression. Angle depression basically says this, like pretend like you're in a plane. Oh my gosh, plane, wow, look at that beautiful plane. You're in the cockpit of this plane and I say, hey, look down to the ground in front of you, you would look straight out and then you'll look down. That would be called an angle depression, like looking down. Depress means like push something down. So that's essentially what depression means. Okay, all that to say this. If I'm talking about an angle, I actually have an angle, 35. I didn't earlier. Earlier, I just said A because I didn't know the angle. Now I actually do. So let's just label your sides real quick. You have the opposite, you have the adjacent, and you always have your hypotenuse. So in this case, we know what is the angle, we know the shadow, and we know we need to figure out the heights. So of the three trig identities, it's best if we pick an identity that involves the opposite and the adjacent. We should pick that because we know information about the adjacent and we want to know information about the opposite. So the one that includes both of the opposite and adjacent is tangent. So tangent of the angle, which is 35, equals the opposite side, which is x, over the adjacent side, which is 120. Which expression represents the height of the tower? As in, hey, if you were to solve for x, how would you solve for x? Well, we set up our equation with the tangent. Tangent 35 equals x over 120. Your goal is to solve for x. I don't like x and 120 hanging out together. Let's move that 120 to the other side. Well, right now you're dividing by 120. We always want to do opposite operations, right? That's kind of why we subtracted earlier 49. That's kind of why we took the square root. You want to do the opposite. So the opposite of division would be multiplication. So instead of dividing by 120, let's multiply by 120. Now, typically in geometry class, what you would then do is you would get a calculator. You would say, okay, 120, tangent of 35, make sure you're in degrees. But typically on the TSI, we kind of stop there. We're kind of say, hey, don't worry about the TI-84 part. Just set it up. Right? I trust you can type it in from there. The TSI typically does that. I can't always say they will or won't. They might make this a TI-84 question as well. You know, depends on what they want to do. Last question, if you haven't already, try your best. It's a weird one, but it's a good one. Perfect. Hey, in this right triangle, ABC, I know that angle C is the 90 degrees. A or B, doesn't really matter the location of those. I'll just make A up here. That's kind of what we did earlier, which makes this one B. This is important. Notice, what is cosine of A? Cosine of A is 12 over 13. So we can label some sides here in reference to A. But they're asking for the sine of B. So what I'm going to do, all the stuff about cosine, I'm going to label that in red. And all the stuff about sine, I'm going to label in B. So cosine of A represents the opposite side. Oh, sorry, let me label my triangle. Opposite from A, adjacent to A, and then the hypotenuse. Oh, wait, the hypotenuse is always that part. So I'm going to put that like a mixture of both, or just put it in black, okay? But if you look at it from the reference of angle B, this side over here is actually the opposite side. And this side over here is actually the adjacent. So when I asked you to label 12 over 13, we had to label it in reference to cosine, or mainly cosine of A. So cosine of A, well, by definition, cosine is your adjacent over your hypotenuse, which means your adjacent is 12 and your hypotenuse is 13. So we have this as 13, and the adjacent for A is going to be 13 as well. Why did I say 13? I meant to say 12. Don't know where I got 13 from. What is the sine of B? Well, by definition, sine is your opposite over hypotenuse. So the side that is opposite of B is 12, and the hypotenuse is 13. So actually, it's also 12 over 13. So this answer is actually 12 over 13 as well. So the cosine of an angle, it's actually the same thing as the sine of the other angle. The cosine of A was equal to the sine of B. It matters what we identify as the angle, especially when you make a right triangle. A little bit longer video, but it's totally fine because it was an important subject. So if you have any questions, be sure to let me know. If not, thank you so much for watching. Hope you have a great rest of your day. And as always, go Mavericks.